Welcome back to the deep dive. This one is specifically for you, our Follow Video audience.
Hi, everyone.
Today, our mission is, well, it's pretty crucial for any serious learner, mastering those midterms.
Right, and specifically moving beyond those study methods that feel productive but honestly don't deliver much. We're talking about passive stuff, low-yield techniques.
Exactly. We often just default to rereading our notes, maybe highlighting half the page yellow.
Feels like you're doing something, doesn't it? But we've been digging into a whole stack of academic research here. Cognitive psychology, guides for med students who face just mountains of information.
And the consistent finding, those traditional habits, the rereading, the highlighting, they're just not that effective, scientifically proven.
Yeah, the retention rates are surprisingly low, often only around, what, 10 to 20% long term?
You know that feeling, right? You read a chapter 5 times, you feel like you know it, but then you close the book and poof, it's gone.
That poof happens because passive review creates something the researchers call the illusion of knowledge.
Illusion of knowledge, I like that.
It means you recognize the material when you see it again. But recognition isn't retrieval. You feel confident because the words look familiar.
But when you actually have to produce the answer yourself on a test,
The mental connection just isn't strong enough. So our goal today is to pull out 5 evidence-based study techniques,
proven technique.
proven techniques that can seriously boost your long-term retention. We're talking potentially up to 80% if you really implement them correctly.
Okay, so for each one, we'll break down what the hack actually is, why the science says it works, and then give you a really simple step-by-step way to use it, like right away.
Let's dive in. The first big concept is the power of retrieval. This is about making your brain work during the learning process.
Right, not just absorbing, but actually pulling information out. Our first 2 hacks really focus on this shift.
Exactly, from passive input to active retrieval.
So let's start with hack number 1, active recall. This is sometimes called the testing effect. And what we mean here is deliberately trying to remember information without looking at your notes.
It's redefining testing. Testing isn't just assessment anymore. It's a core part of the learning process itself.
That change in mindset is huge, isn't it?
It really is. And the science behind it is solid. Active recall strengthens those neural pathways. Psychologists call it the generation effect.
Generation effect.
Yeah, you're generating the answer, not just recognizing it. It's like mental weightlifting for your brain cells.
I like that analogy.
Research consistently shows massive differences. One study found students using retrieval remembered about 80% of the material a week later.
80%. And the ones who just reread?
Only about 36%. That's a huge gap in efficiency.
Wow. And what I found fascinating in the research was that it's not just about getting the answer right when you recall.
No, that's key. Even unsuccessful attempts to retrieve something, as long as you get the correct feedback afterward, actually enhance learning later on.
So the effort itself matters,
Yeah.
the struggle.
The mental effort is the magic ingredient, basically.
Okay, so how do you actually do this? What's the actionable step?
Simplest way. Turn your notes into questions. Stop just reading a statement like, the mitochondria is the powerhouse of the cell.
Right.
Instead, write down, what is the function of the mitochondria? Or explain the role of the mitochondria. Then, cover the answer and force yourself to state it.
Create that friction. And this is where tools can help, right? Flashcards.
Absolutely. Physical flashcards are great. Digital ones too. Anki, Quizlet, they're popular for a reason. They automate some of this.
And for technical subjects, like math or physics.
The principle is the same, but the application looks different. Force yourself to solve problems without looking at the worked example first. Struggle with it. That struggle builds the strong memory trace.
That effort, that struggle, leads perfectly into the next one, doesn't it?
It does. Hack number 2, spaced repetition.
So this isn't just repeating, it's repeating smartly.
Precisely. It's about strategically reviewing information at increasing intervals over time. It's the absolute opposite of cramming.
Which, let's be honest, is what most of us tend to do. Why is spacing so important, though? If I just learned something, wouldn't reviewing it right away be best?
That feels intuitive, but it runs smack into one of the oldest findings in memory science. Hermann Ebbinghaus's forgetting curve.
Ah, yes, the forgetting curve. Sounds ominous.
It kind of is. Ebbinghaus showed way back in the 1880s that we forget things incredibly fast. You can lose like up to 70% of new factual stuff within 24 hours if you don't revisit it.
70% in a day, that's discouraging.
It is. But spaced repetition is the direct counterattack. By spacing reviews out, you flatten that curve. Studies show it can boost long-term retention by up to 74% compared to mass practice, like cramming.
Okay, and there's specific research on the timing of those spaces, right? It's not just random intervals.
Exactly. Researchers like Bjork and Bjork talk about the optimal spacing effect. You want the review to be a little challenging, but not impossible.
So you review it just about when you were starting to forget it.
That's the sweet spot. Waiting a bit, letting it get slightly harder to recall, actually strengthens the memory more when you do retrieve it.
And the research suggests expanding intervals are better, like review after 1 day, then maybe 6 days, then 16 days.
Yes, expanding retrieval practice generally seems to be more effective than fixed intervals, especially for information that might get confused with other things you're learning.
Okay, but practically, tracking review dates for 10 different concepts across multiple subjects sounds like a logistical nightmare. Wouldn't setting that up take more time than studying?
That's where technology comes in again.
Yeah.
You don't have to manage the schedule manually. That would be a nightmare.
Good.
Use digital tools.
Yeah.
Anki is specifically built for this. RemNote integrates it. Even Quizlet has smart features now. These apps use algorithms.
Algorithms.
Yeah, they track how easily you recalled something and automatically schedule the next review, maybe in 3 days, maybe in 3 weeks. It takes the scheduling burden off you.
So you just focus on the actual recall practice.
Exactly. The app handles the when.
Okay, so active recall and spaced repetition handle the how and when of pulling information out. Let's shift gears. What about understanding things more deeply?
Good transition. That brings us to hack 3. The Feynman Technique.
Named after Richard Feynman, the physicist.
The very same. Nobel laureate, brilliant communicator. This technique is basically a 4-step process for mastering a concept by explaining it in the simplest terms possible.
Like teaching it to a kid.
Pretty much. Imagine you have to explain it to a smart 12-year-old who knows nothing about the topic.
Why does that work so well?
The power is in the simplification. It forces you to process the information deeply and identify exactly where you get confused.
Yeah.
You can't hide behind jargon or fancy terms.
It exposes the gaps in your own understanding.
Precisely. It boosts metacognition, your awareness of what you know and don't know. Studies on this kind of self-explanation show students can score up to 30% higher on tests afterward.
Okay, so what are the 4 steps? How do you actually do the Feynman technique?
Step 1. Pick your concept. Take a blank piece of paper and write down everything you know about it. From memory, no notes.
Step 2.
Try to explain it in simple language. Cut out all the technical terms. Or, if you use one, define it simply. Use analogies. Make it concrete.
Step 3 is probably the tough one.
It's the moment of truth. Identify where your explanation felt weak or confusing, or where you had to gloss over something. Be honest. That's where you need to learn more.
So you go back to your notes or textbook, but only to fill those specific gaps.
Exactly. You target your learning. Then, step 4. Review your explanation. Simplify it further. Refine the analogies. Practice explaining it again until it's crystal clear and smooth.
Until you could actually teach it to that 12-year-old.
You got it. If you can do that, you truly understand it.
Okay, Feynman is about deep understanding of one thing. What about connecting different ideas?
That leads us nicely to hack 4, interleaving.
Interleaving sounds interwoven.
It is. It means mixing up different but related topics or types of problems within a single study session.
So instead of doing all of Chapter 3, then all of Chapter 4.
You mix them up, you do a bit of Chapter 3, then a bit of Chapter 4, maybe back to a different concept in Chapter 3, then something else.
No, wait a minute. My instinct, and I think most students' instinct, is blocked practice. Master one thing completely before moving on. Doesn't interleaving just create confusion?
It feels harder in the moment. That slight confusion or difficulty is actually the benefit.
How so?
Because interleaving forces your brain to constantly figure out which strategy or type of knowledge is needed for this specific problem or question. You're not just executing the same procedure over and over.
I have to discriminate. Choose the right tool for the job each time.
Exactly. Blocked practice makes you good at running one specific procedure. Interleaving makes you good at selecting which procedure to run. That leads to much stronger, more flexible recall later on.
And the research backs this up.
Well, yeah. It's been shown to improve problem-solving skills by like 40 to 60% in some studies. Think about exams problems are usually mixed up, not blocked by chapter. Interleaving prepares you for that reality.
Okay, so practically speaking, how would you interleave?
If you're studying multiple subjects, maybe do 30 minutes of physics problems, then switch to 30 minutes of history reading, then maybe back to a different type of physics problem.
And within one subject, like math.
Don't do 20 differentiation problems followed by 20 integration problems. Mix them up. Do a differentiation problem, then an integration one, then another differentiation, maybe a related rates problem. Keep your brain switching gears.
That constant switching builds more robust, transferable knowledge.
Precisely. It holds up better under pressure.
All right, we've got recall, spacing, deep explanation, and mixing things up. What's our final hack?
Our final one, hack 5, is about making knowledge stick. It's called concrete examples.
Making abstract ideas less.
Floaty.
Exactly. It's about attaching specific, vivid, and often personal examples to abstract concepts. Why does that work? Just making it more relatable.
It leverages something called context-dependent memory. It grounds the abstract idea in something tangible, something your brain can hook onto. And the sources are clear. Generating your own examples is key.
Not just understanding the examples in the textbook.
Right. Students who create their own examples retain the information 2 to 3 times more effectively. Your own life, your own observations, that context makes the memory much stronger.
Can you give us a quick example?
Sure. Let's say you're learning an abstract economic concept like opportunity cost, the value of the next best alternative you give up.
All right.
Instead of just memorizing the definition, create a personal example like, the opportunity cost of me coming to this study session tonight was missing that movie premiere my friends went to. It's specific, personal, slightly painful maybe.
Yeah, that makes it memorable. So the action step is?
Make it a rule. For every important abstract concept you learn, whether it's in law, science, philosophy, whatever, consciously create a concrete, personalized example.
Write it down.
Absolutely. Maybe even keep a running list in your notes, like a personal example library for quick review.
So when you see opportunity cost on the exam, you don't just see the definition, you see yourself missing that movie.
Exactly. The vivid personal story pops into your head, and it brings the abstract definition along with it. Makes it much stickier.
Okay, so let's recap. We've covered active recall testing yourself, spaced repetition reviewing at increasing intervals, the Feynman technique explaining simply, interleaving mixing topics up, and concrete examples making it personal and vivid.
That's the toolkit. It's a really powerful system, not just for acing midterms, but for building knowledge that actually lasts. Durable knowledge.
And that durability, that efficiency is critical, which brings up an interesting point from the sources we looked at.
Yeah, what's fascinating, maybe even a bit concerning, is that these methods, all scientifically validated to work best, often aren't explicitly taught.
Even in really high-stakes environments.
Especially there. The research suggests many professional schools, like medical schools where you have this insane volume of facts, they rarely teach students how to learn effectively using these principles.
So students are just left to figure it out themselves, often defaulting to those inefficient methods we started with.
Exactly. Which leads to a kind of provocative question for you, the listener, to think about as you start applying these hacks.
Okay.
If cognitive science clearly shows us the most efficient, most effective ways to learn and retain information long term, why isn't this standard practice in our education system? Why does the burden still fall almost entirely on the individual student to discover and implement these time-saving, mastery-building techniques?
That's a really good question. Why isn't learning how to learn part of the curriculum?
Something to ponder as you design your own study plan using these hacks. You now have the tools to take control, save time, and build real understanding.
We certainly hope this deep dive gives you that edge you need, not just for midterms, but for all your learning going forward. Thanks for joining us.